Assalamualaikum and salam sejahtera class. Okay, for today's video, we will proceed with our new chapter, which is chapter 8 entitled Vectors. So, in this chapter, our first subtopic is subtopic 8.1, Vectors. And now, let's look at our learning outcome for this subtopic, which is the first one. Students should be able to, number one, compare and contrast between vectors and scalars, and hence identify whether a quantity is a vector or a scalar by providing justification. Okay, learning outcomes number 2 is represent vectors by using directed line segments and vector notations, and hence determine the magnitude and directions of vectors. And number 3 is make and verify conjectures about the properties of scalar multiplications on vectors. And our last learning objective, which is learning objective number 4, is make and verify conjectures about parallel vectors. Assalamualaikum and salam sejahtera class. Okay, for today's video, we will learn a new chapter, which is chapter 8 vectors. So in this video, we are going to learn subtopic 8.1. Okay, let's look at our learning outcomes for today's video, which is the first one. Okay, students should be able to, number one, compare and contrast between vectors and scalars, and hence identify whether a quantity is a vector or a scalar by providing justifications. Number 2, represent vectors by using directed line segments and vectors notations, and hence determine the magnitude and direction of vectors. Number 3, make and verify conjectures about the properties of scalar multiplications on vectors. And the last one is make and verify conjectures about parallel vectors. Okay class, let's look at our first learning objective, which is learning objective number 1, comparing the differences and identifying vectors and scalar. So in this learning objective, you have to differentiate and also identify which one is the vector and which one is the scalar quantity. Let's look at this one. Okay, in our daily life, there are various quantities with magnitude and direction, and quantities with magnitude but without direction. Okay, a quantity that has magnitude and direction is called a vector quantity, while a quantity with magnitude but no direction is called as a scalar quantity. Okay, this one actually for vector quantity and scalar quantity you already learned in chapter 1 in physics subject, isn't it? So if you can recall back from what you have learned during your physics subject, then you can apply in this maths lesson. Okay, let's look at this one. Okay, I recall back to you. Okay, vector quantity, quantity that has magnitude and direction, while scalar quantity, a quantity with a magnitude but no direction. Okay, remember the two terms, which is vector quantity and scalar quantity. Okay, let's look at this one. Okay, observe the following situation carefully. Okay, let's look at the first one. This one is, as you can see, this one is a beaker inside the refrigerator. Okay, temperature of a liquid inside a refrigerator is negative 12 degrees Celsius. Okay, temperature. The temperature inside the refrigerator is negative 12 degrees Celsius. So what does it mean here? Okay, is it a vector quantity or a scalar quantity? Okay, let's look at this one. Okay, vector quantity have magnitude and direction. Okay, what is magnitude? Okay, magnitude means size or value or length or distance. It is something that have a value. Okay, remember, direction direction means that direction to the north, south, east or west and so on. Okay, so let's look at the first one here. Okay, temperature of a liquid inside a refrigerator is negative 12 degrees Celsius. So from here, what can you consider this one? Is it vector or scalar? So this temperature represent a scalar quantity. Why? Because this situation, it only have a magnitude which is negative 12 degrees Celsius. But is it have a direction for temperature? Is it have a direction or not? So no, there is no direction. So if there is no direction but it have a magnitude, then we call it as scalar quantity. Okay, let's look at the second example. Okay, a moving car on the road is heading south with speed of 80 km per hour. Okay, remember, look at this one, this example. Okay, the magnitude is 80 km per hour. And the direction, is it have a direction or not? Is the car have a direction or not? Yes, because the road is heading south. South is represent the direction. So this situation, we can consider as a vector quantity. Okay, remember. Okay, now look at this one. Can you determine which situation involve a vector quantity and a scalar quantity? Okay, I already explained to you just now. Okay, how do you identify whether the quantity is a vector quantity or a scalar quantity? I also already explained to you based on the definitions of vector quantity and also the definition of scalar quantity. Okay, let's look at the next one. Okay, let's look at the next one. Okay, the following table shows the example of quantities with vector and scalar and quantities without both vector and scalar. Okay, let's look at the first row. Okay, for vector. Okay, look at this one. 50 Newton of force applied to a box. Okay class, look at this one. Okay, for vector, 50 Newton of force applied to a box. Okay, this one is considered as a vector quantity. Why? Okay, 50 Newton is the magnitude. So where is the direction? Okay, let's look at this one. Okay, just imagine this is a box. Okay, this is a box. Okay, and okay, 15 Newton of force is applied. So force can be pull, can be push. Okay, just imagine this one is the push. Can be push, can be pull. Okay, can be move to the upright. Okay, and also can be pull down. Can be pulled down. Okay, so that's why force is considered as a vector quantity. Okay, let's look at this one, scalar. Okay, Auni's height is 1.48 meter. 1.48 meter. So the height of Auni, it's only have a magnitude which is 1.48 meter, but it doesn't have a direction for height. Okay, so that's why the height here is a scalar quantity. Okay, let's look at this one without vector and scalar. So this is the example of quantity that without vector and scalar quantity, which is pressure and tension. Okay, remember this one. Okay, let's look at below here. Okay, velocity of a car is 90 km per hour and is heading east. Okay, as I mentioned to you just now, so it means that this one is the magnitude and heading to the east. So this one is the direction. So that's why we call this situation as a vector quantity. Okay, so let's look at the scalar. Okay, the area of a tile is 120 centimeters square. Okay, this one, it only have a magnitude, but it doesn't have a direction. Area, is it area have a direction? No, area cannot be possible to have a direction. So, this one is, we call as a scalar quantity. Okay, let's look at this one. Without vector and scalar, so conductivity of metal. Conductivity of metal, this is the example of quantity that is not a vector and also not a scalar. Okay, That's it. Okay, class, let's look at the next example. Okay, can you differentiate between distance and displacement, speed and velocity, and also mass and weight? The following table shows the differences between those quantities. Okay, let's look at the first one. Okay, distance. Distance is considered as a scalar quantity. Okay, let's look at the definition of the distance. Distance is the total length of track that is passed by a moving object. Okay, distance is the total length of a moving object. Remember this one. So distance is considered as a scalar quantity because it doesn't have a direction. It only have a magnitude. Okay, let's look at the vector quantity. Okay, displacement. Okay, for displacement is the quantity that can be classified as a vector quantity. Why? Because let's look at the definitions of the displacement. Okay, the displacement is the length of the shortest line segment between the starting point and the terminal point and involve the direction from a reference point. Okay, this one, displacement, we consider as a vector. Okay, why? Okay, let's look at the example beside here. Okay, let's look at the example. Okay, this one is the situation given to you. A car moved 40 kilometers to the north, okay. Okay, this one, remember. Okay, alright. Okay, this one is the north, west, south, east. Okay, so a car moved 40 kilometers to the north, okay, to the upright, 40 kilometers to the north, and then after that, the car moved 30 kilometers to the east. Okay, so this is the starting point and this is the finish point. Okay, so for distance, okay, distance is the total length of a moving object. So the object moved from here and then to here and then here. Okay, so let's calculate the distance. Okay, so 40 plus 30. So you will get the answer is 70. So this one is the magnitude only. There is no direction for distance. Okay, let's look at the displacement. Okay, this displacement is the length of the shortest line segment. Okay, remember length of the shortest line segment. Instead of moving to this one and this one, so you for displacement you need to choose the shortest distance. So the shortest distance is by using this way. Okay, by using this way, the shortest distance. Okay, so but if even if you use the shortest distance, but you need to make sure that the starting and the finishing point is the same. Okay, so this is the displacement. So we know that the direction of the displacement is the at the shortest one. Okay, so displacement is 50 kilometer. How you got 50? 40 square plus with 30 square and then you square root. Then you will get 50 kilometer. So we know that the displacement is 50 kilometer. Okay, now 50 kilometer. This is the displacement. Okay. And then after that, what should you do? Okay, now class, let's look at the next example. Okay, speed. Speed is considered as a scalar quantity. Okay, speed. Let's look at. Okay, speed considered as a scalar quantity. Okay, let's look at the definition of speed. Okay, speed is the rate of change of distance against time. Okay, from here you already know that the speed use the distance. Okay, the formula involve distance. So it means that okay, it involve distance. So if it involve distance, before this you already know that distance is the scalar, isn't it? Distance is the scalar quantity. So for speed, it also considered as a scalar quantity. Okay, remember that one. Okay, now look at the velocity. Velocity is the rate of change of displacement against time. Okay, the value becomes negative if the object is moving in the opposite direction. Okay, before that, look at velocity. Velocity, formula of velocity, it used displacement against time. So we know that displacement already in vector quantity. So we can consider velocity also vector quantity. And also, why? Because the value of the velocity will become negative if the object is moving in the opposite direction. So we know it's already have a direction. So that's why velocity considered as a vector quantity. Okay, let's look at the example here. Okay, Haziq is moving from A to B. Okay, this one. Haziq moving from A to B with the same speed and velocity, which is 90 km per hour. After that, he turned back from B to A with the speed of 90 km per hour and velocity of negative 90 km per hour. So from here, velocity Haziq turned back from B to A. So that's why velocity will become negative 90 km per hour. So this is the direction. So that's why velocity is the vector quantity and speed is the scalar quantity. Okay. Now let's look at the next one, mass. Okay, mass also considered as a scalar quantity. Okay, look at the definition of mass. Mass is the amount of matter that an object contains. The value doesn't change according to the location. So it means that mass doesn't have a location. So that's why mass is the scalar quantity. Okay, let's look at the weight. Weight is the pull of gravity on an object. The value is not constant and depends on the gravitational force of the location. Okay, so weight is considered as a vector quantity. Okay, let's look at the example. Okay, the mass of an astronaut when he is on the moon is 120 kilogram with weight of 200 Newton, while the mass of the astronaut is 120 kilogram and the weight is 1200 Newton when he is on the earth. So this is why the example of the weight and mass. Okay, you can see here this one. Okay, let's look at the next one. Okay, look at the next one. Okay, we go to our learning objective number 2, which is representing the vector using directed line segment and vector notations and determining the magnitude and directions of vector. Okay, class. For learning objective number 2, okay, let's look at the box here. Okay, vector can be represented using a line segment with an arrow. Okay, this one. This is what we call as the a line segment with an arrow. This one arrow, or better known as a directional line segment. This one. This one we call as a directional line segment with an arrow. Okay. The arrow represent the direction. This one, this arrow represent the direction. So from here you will know that it is from A to B. Okay. So and while the length of the line represent the magnitude of the vector. The length of the line. Okay, this one. The length of the line here. This one from here until here, the length of the line represent the magnitude of the vector. Okay, and as an example, vector of a sailing boat, okay, move 7 kilometer to the east. 7 kilometer to the east. Okay, where is the east? Okay, sorry. Okay, wait. Okay, this one is the north, west, south, east. Okay, look at the example. As an example, vector of a sailing boat move 7 kilometer to the east. 7 kilometer to the east from point A to point B can be represented by the directional line segment as shown in the diagram on the right. This diagram. So this one represent a sailing boat move 7 kilometer to the east. So to the east means to the right lah. This one to the right. Okay, with 7 kilometer. Okay, from point A to point B Okay, this one represented by the directional line segment. Okay, this one the length of from A to B is 7 kilometer. Okay. Okay, now look at this one. Point A is the starting point. Okay, this one. This is what we call as point A. This is the starting. This is the starting point. Okay. And this one is the point B is the terminal point. This one. This one is the terminal point. Okay, remember this one. Okay, remember this one is the starting point and this one is the terminal point. And also, vector can also be represented with the notation as below. So this one is the vector AB, or this one, the bold letter AB, or vector A, or bold letter A. Okay, this one. This is the representations of vector. Okay, let's look at the next one. This is for vector. Now, look at the magnitude. For magnitude of the vector can be written as, okay, this one is the vector. So, if magnitude, so you just have to put the modulus here. So, magnitude of vector AB, okay, magnitude of vector AB, and this one also magnitude of vector A. This one is the magnitude of vector A. Okay, this one, the modulus here represent the magnitude. Okay, remember that one. Okay, class, we proceed to the next one. Okay, so a vector can be many types. Okay, first of all, it can be zero vector, and also it can be, if there is two vector, so the vector can be the same. And also the next one is negative vector. So vector also can be negative. So let's look at the first one. This one, zero vector. Zero vectors are vector that consists of zero magnitude and the direction cannot be determined. Zero vector can be represented as this one, okay? Zero vector. This is what we call as, if you look at this one, so it means that this is a zero vector. Okay, for example, a race car is moving in the round shaped track. Okay, round shaped track like this. Okay, just imagine this is the track of racing car. Okay, this is the finishing line and also the starting line. Start, finish. Okay, so a race car is moving in the round shaped track. The starting point and the terminal point of a moving car are the same. So like this lah. This is the starting point and also this is the finishing point. Okay, thus the vector of a displacement of the race car is zero vector. So this is the displacement for the racing car is zero. Okay, zero vector. Okay, this one. This is the example of situation for zero vector. Okay, remember? Okay, let's look at the next one. Okay, two vector are the same. Okay, two vector are the same if both vector consist of the same magnitude and direction. Okay, like this. Vector AB is equal to vector CD. Okay, let's look at the example. Okay, Rakesh and Fauzi are riding bicycle at the same speed and in the same direction. The velocity vector V for both movement are the same. Thus, velocity Rakesh is equal to velocity Fauzi. Okay, velocity vector of Rakesh is equal to velocity vector of Fauzi. Okay, this one. Okay, two vector are the same if there is the same speed and same direction. Okay, remember the two important things. Okay, let's look at the next one. Okay, let's look at the next one. Alright. Okay, look at the next one here. Okay, so a vector is negative. So how? Okay, a vector is negative if the vector consists of the same magnitude but is moving in the opposite direction. Okay, vector BA is a negative vector of vector AB, and it is written as vector BA is equal to negative vector AB. Okay, for example, okay, look at the example. The two train A and B move past each other at two parallel railway at the same speed but different direction. Okay, I draw for you. Okay, just imagine this is the this is the train A. This is train A, and this is train B. Okay, wait. Okay, this is train B. Okay, train A move in front while train A move to this direction and train B move to this direction. So we can consider as this one. Okay, vector A. Okay, vector A is equal to negative vector B, like this. Okay, based on the situation. Same goes as this one. Okay. Okay, let's look at this one. Okay, what else? The information given to you. Two trains A and B move past each other at two parallel railway at the same speed but different direction. Okay, the velocity of the train A has a positive value while the velocity of train B has a negative value. So this is represented as like this. Okay. Okay, now class, let's look at example 2. Okay, for example 2, draw and label the following vectors. So look at A. A is vector SR represent displacement of 12 km to the east. Okay, 12 km to the east. So let's draw. Okay, this one. Okay, before that, this one is the north, west, south, east. Okay, let's look at A. Okay, ASR represent the displacement of 12 kilometer to the east. So SR. So to the east is to the right lah. Okay, you draw it like this. Okay, this one S. Sorry, this one is R. Okay, so you need to draw the directional line segment. Okay, so SR. So this one like this. Okay, and then what should you do? Okay, you already draw this one, and then if you look at this one, 12 kilometer. Okay, represent 12 kilometer represent the length of this one. So just imagine this one is 1 cm, 1 cm. This one is 1 cm. So 1 cm represent 6 kilometer. So this one is 2 centimeter. 2 times 6, you got 12 kilometer. Okay, so this is how you do it. Okay. Okay, now let's look at B. Okay, B, vector P represent force of 7 Newton to the south. Okay, 7 Newton to the south. Okay, so south is downward, right? So you draw it downward. Okay, this one, and then look at this one. This one is the vector P. So for this notation, you need to draw it like this. Okay, P. Okay, like this. Sorry. Okay, so downward. Okay, so from south. Okay, vector P represent force of 7 Newton to the south. Okay, 7 Newton to the south. Just imagine this one is 1 cm, and this one is another 1 cm. So 1 cm represent 3.5 Newton. Okay, so that's it. This is how you do it. Okay, we done already for B. Now look at C. Okay, C. Okay, vector R represent velocity of 70 meter per second to the left. Velocity of 70 meter per second to the left. So to the left means it moves to the left lah, like this. Okay, so this is arrow is to the left lah, and this one represent the R. So vector R you need to write down like this. Okay, bold R, okay, bold R. Okay, now why to the left? Okay, to the left 70 meter per second. Okay, so just imagine this is 1 cm. Okay, this is another 1 cm. So now 1 cm represent, okay, 1 cm represent how many? 1 cm represent 35 meter per second. So that's it. This is how you do it, okay? Okay, if the notation is vector SR like this, so you need to label like this. Okay, if the notation given to you like this, but it's still a vector, but the notation, the type of notation is different. So vector piece, then you have to do it like this. Same goes as for the bold one. Okay, like this. So you need to draw it like this. Okay, that's it. Okay, class, let's look at example 3. Okay, for example 3, the diagram on the right shows a vector AB that represents the displacement of a particle from point A to point B. Okay, from point A to point B. So the question asks you, find the magnitude and direction. Okay, you need to find the magnitude. You need to find the magnitude and directions of the particle from point A. So from point A to point B. Okay, the first thing that you need to do is you need to find the magnitude first. Okay, magnitude A to B. So how is it? Magnitude, the symbol of magnitude is AB. This one, isn't it? Okay, this one. And then look at this one. We want to find this length. Okay, this length. So how? Okay, let's look at this one. Okay, it will form a triangle. So in order for you to find this length, you need to do the Pythagoras Theorem. Okay, let's look at this one. Okay, look at the vertical line. So the vertical line, the box, how many box? So 1, 2, 3, 4, 5. Okay, so this one represent 1 centimeter. So 5 square plus, okay, look at the horizontal. Okay, 1, 2, 3, 4, 5. Also 5. Okay, 5 square, and then you need to square root. Okay, and you will get your answer will be 50. 50, okay? Okay, 50. It is not the final answer. Okay, what should you do? You need to change this one into a surd form. Okay, surd. Okay, remember surd form. Okay, surd form. You need to change into a surd form. So inside 50, what can you get? Inside 50, the value of 50, what is the perfect square? Okay, so the perfect square is 25 times 2. Okay, this one. 25 times 2. So if you, and then we split, okay, we will get this one lah. Okay, and then square root 25, you will get 5, and then multiply with 2 surd 2, okay, and then 5 times surd 2, you will get your answer is 5 surd 2. Okay, so we already get the value of the magnitude. Now the direction. Okay, the direction. Okay, look at the direction. So okay, this one AB is the direction is to this one, right? So if you, okay, this one is the north, west, south, east. Okay, AB, from A to B. So the direction is from here to here. This one AB. So we know that the direction is to the northeast. Okay, to the northeast. So the complete answer is magnitude magnitude of vector AB, okay, is 5 sub 2, okay, and the direction of vector AB is to the what? To the northeast, okay? To the northeast. Okay, that's it. This is the final answer. Okay? Okay, now class, let's look at example 4. Okay, the diagram on the right shows a parallelogram ABCD. Okay, the point P, Q, R, and S. P, okay, let's label. Where is P? This one, P, Q, R, and S is the midpoint of A, B, C, D, and D, A. Okay, respectively. So given that vector AS is equal to vector A, this one. And then vector AP represent this one, vector B. Okay, and vector AJ, where is the AJ? Vector AJ represent vector C. And state the vector of the following in terms of A, B, or C. Okay, remember parallelogram. Okay, remember for parallelogram, okay, you need to remember this one is parallel to this one, and this one is parallel to this one. Okay, remember. Okay, let's proceed to question A. To question A, the question asks you to find a vector as D in terms of A, B, or C. So either in terms of vector A, vector B, or vector C. So look at SD. So where is SD? SD is in here, right? Okay, SD is here. Okay, S is the midpoint. Okay, what is so the question asks you to state the vector. So SD, okay, SD is equal SD. The length of SD is equal to the length of AS, isn't it? Okay, and then AD is the parallel to BC. So as you know, we already know it is already given to you the vector for AS, which is this one, vector A. So if the question asks you to find the vector SD, so it means that SD, okay, the direction is equal. So the vector also this one, also A. Okay, so we know that this one, this is the answer. Okay, so let's look at B. Okay, B is CJ. Okay, where is CJ? C, where is C? Okay, this one, C and J. Okay, as you can see here, the direction here and this one, AJ. CJ and AJ. Okay, AJ is, the vector AJ is equal to vector C, isn't it? But this one, okay, the question asks you to find the vector CJ. So CJ, so the direction is here, okay, which is opposite to the direction of AJ. But the vector here is equal. And then you just need to, just because of AJ and CJ is in the opposite direction, so the answer will be negative vector vector C. So negative vector C, okay, like that. Okay, and then now let's look at C. Okay, for C, RJ, vector RJ. Okay, vector RJ. So where is RJ? RJ, where is R? Where is it? Okay, R and J, this one. Okay, I erase for you because it's too crowded. Okay, this one. Okay. Okay, let's look at RJ. RJ. So RJ, the direction is from R to J. Okay. So RJ is equal to what? Okay, this one A, this one C, this one B. So RJ, okay. Rj is the, okay, if you can see here, where is Rj? Rj is, R is the midpoint of DC, P is the midpoint of AB, S is the midpoint of AD, and Q is the midpoint of BC, and J is the midpoint of PR. So if this one, we already know the vector SD is A, isn't it? Okay, vector SD is A. Okay, now this one, SD and RJ, this is the opposite direction. RJ is the opposite direction of SD, isn't it? So RJ is negative A vector, negative vector A. Okay, this one. Okay, let's look at D. D is JQ, vector JQ. So where is JQ? J and Q. So this one, JQ. Okay, now this one, P is the midpoint. Okay, this one AP. So this one also, it will also B, vector B. And this one, okay, this is the same parallel, isn't it? PB and JQ is parallel too. And then we know that if this is parallel to this one, so we know that JQ is equal to vector B. Okay, this one. So that's it. That is how you do it. Okay. Okay, class. Let's proceed with learning objective 3, which is making and verifying conjectures about the properties of scalar multiplication on vectors. So let's observe the following cases. So let's look at case number 1. Okay, observe vector A. Okay, this one, observe vector A, vector AB, vector CD in the diagram on the left. This one, this diagram. So it is found that vector AB, look at AB. Okay, the directions of AB and this one is the same, isn't it? Which is to the right. So it is found that vector AB is equal to, okay, equal to what? Okay, let's look at this one. Sorry. Okay, this one is vector, this one, 1, 2, 3, 4, 5, isn't it? So, okay, so let's look at this one, vector AB. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, it means that vector AB equal to 2 times vector A, okay? So, we can consider this one as 2 vector A, okay? So, this one, CD, okay? We done already for this one. Now, look at vector CD. Okay, CD. So, calculate the box 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this one is 5, this one is 15. So how many times? It is 3 times vector A. So equal to 3 vector A. Okay, like this. Okay, we done already for this one. Okay, now let's look at this one. Given that magnitude, okay, the question asks you to find the magnitude. Okay, look at this one. Magnitude of vector A. Okay, wait. Magnitude of vector A. Sorry. Okay, as you can see here, magnitude for vector A is 1, 2, 3, 4, 5. So 5 unit. Okay, 5 unit. Okay, this one is 5 unit. Okay, now let's look at vector magnitude of vector AB. So magnitude of vector AB is, okay, so you just need to look at this one. So 2 times a vector A, isn't it? So the magnitude is 2 times 5. Then you will get, your answer is 10 unit. Okay, let's look at this one. Magnitude of vector CD. Okay, CD is 3 times a vector A. So it means that 3 times 5 unit. 5. So 5 times 3, 15 unit. Okay, that's it. That is how you do it. Okay. S. This one also S. Okay, units. Alright. Okay, class, let's look at case number 2. Okay, observe vector B, vector EF and GH in the diagram on the left. Okay, it is found that vector EF, okay, let's look at vector EF. Okay, this is already given to you, the vector. Okay, vector B, okay, look at how many box, 1, 2, 3, 4, 5, 6, 7, 8. So ada 8 unit. Okay, so let's look at this one. It is found that vector EF is equal to, okay, EF is equal to what? Okay, let's look at this one. We know that the 8 unit represent vector B. So let's look at how many unit for vector EF. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, this one there is 16 unit. Okay, let's look at this one. This is the direction of the vector, which is to the right. But this one, okay, EF, vector EF, the direction is opposite direction, which is to the left. So you just need to output negative first. Okay, and then after that, okay, 8 unit represent, okay, B, vector B represent 8 unit. Okay, so if there is 16 unit, so it is represent to B, to vector B. Okay, this one, negative to B. Okay, like this. Okay, but you cannot do it like this. You need to put bracket in the value here because there is the negative here, so you need to put the bracket. Okay. Now let's look at vector GH. Vector GH. Okay, this one also, okay, vector GH. But then the direction is on the opposite direction. So you just need to put negative siap-siap, okay? Just you put negative first because the direction is at the opposite. Okay, and then after that, what happened? Okay, look at what happened after that. Okay, let's look at this one, the unit, the number of unit for vector GH. 1, 2, 3, 4. Okay, there is 4 unit. Okay, so just now vector B is equal to 8 unit, but then for vector GH there is only 4 units. So what should you do? So it means that negative 1/2 vector B. Okay, negative 1/2 vector B. Okay, so don't forget, if negative you need to put bracket. Okay, like this. Okay, so now let's look at this one. Okay, so now the question asks you to find the magnitude of vector B. So the magnitude of vector B we already calculate, which is how many units? 8 units. So 8 units. Okay, now let's look at the magnitude of vector EF. Magnitude of vector EF is how many unit? We already calculate, which is there is 16 unit. Okay, units. Okay, and vector GH is 4 units. Okay, we done already. That's it. This is how you do it. Okay. Okay class, based on case 1 and case 2, so we can conclude that multiplication of scalar k with vector A produces a vector Ka, okay, with the condition number 1A, okay, magnitude Ka is equal to K, magnitude Ka is equal to K magnitude A. B, Ka is in the same direction with A if K is greater than 0. Ka is in the opposite direction with A if K is less than 0. Okay, remember this condition. Okay, let's look at example 5. state the following vectors in the diagram on the right in terms of C. Okay, so you need to find the following, state the following vector in terms of vector C. Okay, this is the vector C given to you. Okay, so you need to state what is the vector for vector RS, vector PQ, vector LM. Okay, let's look at one by one based on this vector given to you, which is vector C. Okay, let's look at this one. Okay, so vector RS, this one RS. So the direction is in the same direction. So you just you don't have to put negative. Okay, and then look at the number of unit here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one is 10 unit. Vector RS 10 unit, and then vector C how many unit? 1, 2, 3, 4, 5. Okay, so vector C is equal to 5 unit. So what should you do to find the vector RS? So this one 5 unit, this one 10 unit. So it means that vector RS is equal to 2 times vector C. Okay, so it is equal to 2 vector C. That's it. This is the answer. Okay, now let's look at vector PQ. Okay, vector PQ. Okay, direction is equal, so the same direction. So you don't have to do anything. You don't have to put negative. Okay, you just need to calculate the unit. How many unit for vector PQ? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so if there is 15 unit, so it means that this one 5, this one 15 unit. So 5 times what in order for you to get 15 units? So 3, right? So 3 times vector C is equal to 3 vector C. Okay, so this is the answer. Okay, let's look at vector LM. Vector LM. Okay, vector LM. Okay, if you can see here, LM, the same direction. Okay. Okay, now let's look at the direction LM and also the direction of C. The direction of vector C. Okay, as if you look at here, I erase for you so that you can see clearly. Okay, look at this one. Okay, vector LM and vector C is in the opposite direction. So what should you do? Because we depends on this vector. We depends on this vector to find the vector LM. So since this is opposite direction, so you need to put negative. Okay, and then after that, this is 5 unit. So you need to calculate how many unit for vector LM. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 unit. This one 5 unit, this one 10 unit. So vector LM is equal to 2 times vector C. Okay, this one negative 2. Okay, so you need to do it like this: negative 2 C vector, negative 2 vector C. So that's it. This is the final answer. Okay. Okay, class. Now let's proceed with our last learning objective, which is learning objective number 4. So making and verifying conjectures about the parallel vectors. Okay, look at inquiry 1. Okay, look at the inquiry 1. Okay, aim is inquiry 1. The aim is to create and verify conjecture about the relation between two parallel vectors. Okay, and then the instruction. Look at number 1. Consider the diagram on the right and answer the following question. Okay, look at one by one. Okay, question A. Find the magnitude of each vector. Okay, so we find the magnitude of each vector. Okay, this one. Magnitude of each vector. So vector AB first. Vector AB magnitude. So magnitude you need to put like this. Vector AB, how many unit? So 1, 2, magnitude. So magnitude, you need to find the magnitude. So you need to do the Pythagoras Theorem. So 1, 2, 3. So 3 square plus, okay, 1, 2, 3, 4. 4 square. Okay, and then square root. So what did you get? What is your answer? 3 square plus 4 square, and then you will get 25. Okay, you will get square root 25, and then your final answer is you get 5 units for the magnitude of vector AB. Okay, now look at vector CD. Okay, CD, vector CD. Okay, for vector CD, as usual, use Pythagoras Theorem. 1, 2, 3, 4, 5, 6. Okay, 6 square plus with 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, and then you square root. Okay, what is your answer? 6 square plus 8 square. Then you will get 100. Square root 100. So square root 100 is equal to 10 units. Okay, we done already for the magnitude of the vector. Now B. Determine the ratio of magnitude of vector AB to magnitude of vector CD. Okay, so let's look at this one. AB equal to, not equal, ratio, isn't it? So ratio to CD equal to, okay, this one AB is 5 to 10. Okay, 5 to 10. So we can simplify, it will become 1, 2. Okay, so we done already for B. We already answered for B, which is find, determine the ratio. Okay, C, determine the gradient for the straight line AB and CD. Are the straight line AB and CD are parallel? Okay, so you need to find the gradient. So in order for you to find the gradient, so what should you do? Okay, class. For C, the question asks you to determine the gradient. Okay, for the straight line AB and also CD. Okay, and then the question asks you, are the straight line AB and CD parallel or not? So you need to find the gradient first. So how to find the gradient? Okay, like this. Okay, C. Okay, remember, gradient is equal to vertical distance over horizontal distance. Okay, remember this one. Okay, so let's find the gradient. Gradient of AB, okay, is equal to, okay, vertical distance 1, 2, 3, 4. So 4 over with horizontal distance 1, 2, 3. So 3. So we know that the gradient of vector AB is equal to 4 over 3. So let's look at vector gradient for CD. Okay, look at gradient CD. 1, 2, 3, 4, 5, 6, 7, 8. For vertical distance 8 over with 1, 2, 3, 4, 5 and 6. Okay, 6. So we can simplify this one and we will get 4 over 3. So the question asks you for C is, are the straight line AB and CD are parallel? So since the gradient of AB and gradient CD is equal, so it means that the straight line AB and CD are parallel. Okay, so gradient AB equal to gradient CD. So it means that it is parallel. Okay. Okay, we done already for C. Now let's look at D. Okay, D, the question asks you to express vector AB in terms of vector CD. Vector AB in terms of vector CD. Okay, so given to, okay, wait. Okay, now class, let's look at D. Express vector AB in terms of vector CD. So, okay, look at this one. AB, vector AB, look at the magnitude. The calculation we already done in A. Okay, vector AB is equal to CD. Okay, how many CD? Okay, this one. Okay, AB is 5 unit. AB is 5 unit, and then CD is 10 unit. So it means that, what does it mean? So CD is half of the AB. CD is half of the AB. So 1 over 2 CD. Okay, 1 over 2 CD. So we can represent vector AB is equal to 1 over 2 vector CD. Okay, we can express into this one. Okay, as stated like this, express vector AB in terms of vector CD. Okay, that's it. Okay, let's based on the inquiry we done, okay, let's look at the conclusion. Okay, wait. Let's look at the conclusion. Okay, from the result of inquiry 1, we can conclude that if two vectors are parallel, okay, if the two vectors are parallel, then one vector is product of scalar with another vector. Okay, as we do just now, okay, AB, okay, vector AB is equal to 1 over 2 vector CD. Okay, so it means that this is what does it mean by this one. Two vector, if two vector are parallel, one vector is product of scalar, if the product of scalar with another vector. So one vector, which is vector AB, is the, okay, two vector. If two vector are parallel, then one vector is the product of a scalar with another vector. So let's look at this one. Okay, vector A and vector B are parallel if and only if vector A is equal to k vector B, where k is a constant. So from here, and based on the inquiry we done already, so the value of k is this one. Okay, the value of k, this one. This is the value of k, where k is a constant. Okay, let's look at this one. If vector A and vector B are two non-zero vector and are not parallel, this one, if this one is the case if parallel, so k has a value which is constant lah. Okay, but if vector A and vector B are not two non-zero vector and not parallel, then h vector A is equal to k vector B, thus h equal to k equal to 0. So it means that h equal to 0, h is equal to 0, k is equal to 0 for non-parallel case. Okay, if the two vector is parallel, then it means that k have a value which is the value is constant. Okay, remember that one. Okay class, let's look at example 6. Given vector PQ is equal to A, vector QR is equal to B, vector RS is equal to negative 2A, and vector ST is equal to 4B. So which pair of vectors are parallel? So you need to find the pair. Okay, if you want to find the pair, okay, look at this one. PQ, the vector A, vector PQ equal to A, again, and then, okay, vector PQ is equal to A. So let's find the same unknown. This one A, this one B, so you cannot consider. So this one, RS. So look at vector PQ and vector RS. Okay, if you can see here, vector PQ is equal to A, vector RS is equal to negative 2A. So the pair is, okay, the pair is vector PQ is equal to A, And then vector Rs is equal to negative 2a. So this is the pair of the vector. This is the parallel, okay? And then what should you do? Okay, vector Rs is equal to negative 2a, negative 2a. So a represent the vector PQ. So PQ. Okay, so that's it. So this is the answer. So we know that PQ and RS are parallel. Okay, PQ and RS are parallel. Okay. So let's look at another one. Okay, this one we done already. We pair PQ and RS. So let's look at QR and ST. Okay, vector QR is equal to B. Vector ST is equal to 4B. So what should you do? Okay, vector ST is equal to 4B. 4B. B represent vector QR. So 4QR. Okay, 4 vector QR. So that's it. So we know that ST and QR are parallel. Okay, ST and QR are parallel. Okay, that's it. This is how you do it. Okay. Okay, class. Let's proceed with example 7. Given vector given vector PQ is equal to U and vector QR is equal to 5U. Show that P, Q and R are collinear. Okay, what does it mean by collinear? Have you ever heard the word collinear? Okay, collinear is collinear is a parallel. Okay, so what does it mean by collinear? So collinear means like this. Okay, you have a straight line. Okay, and then there's the point P, Q and R. P, Q and R, collinear. So the 3 point lies on the same line, which is parallel lah. So we obviously P, Q and R are in a parallel line. That's why, because this P, Q and R lies on the same line. So that's why this is confirmed to be a parallel. Okay. So what should we do for this one? How to prove? How to show that P, Q and R are parallel? So you need to do it like this. Okay. You know that given that PQ, vector PQ is equal to U and vector QR is equal to 5U, then you can do it like this. Okay, QR, vector QR, this one, vector QR is equal to 5U, is equal to 5U. So U represent the vector PQ. So 5PQ. Okay, so that's it. This is how you do it. So from here we know that PQ and QR are parallel. Okay, not just this one. You need to, for a collinear, you need to give another information, which is you need to find the common point. Okay, where is the common point in here? Okay, so we know that since PQQR. So Q are in the vector PQ and point Q also in the vector QR. So we know that since common point, since Q is the common point, so so point PQ and R are collinear. Okay. This one, you need to state whether vector PQ, sorry, this one, vector PQ and QRF are parallel or not. And for collinear, you need to state what is the common point here. So in this situation, the common point is point Q, because point Q is inside the vector PQ and point Q also have inside the vector QR. So that's why Q is considered as the common point. And then after that, now we can confirm that points P, Q and R are collinear. Okay, that's it. This is how you show that the point P, Q and R are collinear or not. Okay class, let's look at example 8. Okay, example 8, given that non-zero vector A and B are not parallel. Okay, this case is for not parallel case, okay? And H minus, in bracket H minus 1, A is equal to K plus 5B, where H and K are constant. Okay, find the value of H and K. Okay, for example 8, remember, okay, this one, remember the below statement here. If A and B are two non-zero vector, okay, this one non-zero vector, and are not parallel, okay, not parallel, then H vector A is equal to K vector B. Thus, H is equal to K equal to 0. Okay, so from here we know that this one represent, this one, look at this one. This one represent H. Okay, remember. This one, the whole here represent H, and this one is represent K. And this one, if not parallel, then the value of H and K is equal to 0. So, the question asks you to find the value of H and K. So, what should you do? Okay, you need to do it like this. H minus 1 equal to what? Equal to 0. Based on the concept that you have learned just now. So H minus 1 is equal to 0. So we know that H is equal to 1. Okay, we done already to find the value of H. Now find the value of K. This one is the value of K. This one, the whole thing, K. So K is equal to 0. So you need to, K plus 5, you need to equal with 0. K plus 5 equal to 0. So we know that K is equal to negative 5. That's it. This is how you do it for non-zero vector and not parallel. Okay, that's it. This is how you do it. Okay, remember this concept of the parallel. Okay. Okay, so this is overall our lesson for subtopic 8.1 vectors. Okay, for our next class, we will continue for subtopic 8.2. Okay. Okay, that's it. That's all for today. All right. Thank you so much, class.